Yes, now welcome to today's class. Today I want to discuss with you a topic that is a probability, and specifically I want to look at that is probability density function, the so-called that is PDF. Now I have a question here that consider continuous random variable x as a PDF given by fx. We have kx squared, a range of 0 less or equal to x less or equal to 1, 0 or otherwise. So the first question I have here is that determine the value of k. Yes, so you are supposed now to look at the solution on which you will be in a position of getting the value of k. So having been given the fx there. Now let us look at the solution here. So that is the solution. Let us look at the solution. Now when you look at here, the range here I have that is 0 less or equal to x less or equal to 1. That one means that my upper limit shall be 1 as well as my lower limit shall be 0. And therefore when I just put the integration sign, the upper limit here shall be 1, the lower limit shall be 0. Then I have kx squared. So my kx squared, I shall write here kx squared. Then it is a integration in terms of x. So that is dx. Now under PDF here, there is some NB very important here, that the total probability must be 1. The summation must just be 1. So your work after integrating, you need to be equating to 1. That's a very crucial step or concept, and please remember it, that the summation of the summation under integration here, specifically under PDF here, the total probability must be 1. Now after that, you are supposed just to integrate kx squared in terms of dx. Well, when you integrate this, your work is just to add 1 to the power. So when you take 2 plus 1, fortunately you will end up by having 3. So after adding having 3 there, you divide by the result on the that is a power there. So you will be dividing by 3. So you will end up by having, that is kx cube over 3, because 2 plus 1 is 3. Then you divide by the result. Then the result here, you are required to write the limit in the bracket. So the upper limit is 1, the lower limit is 0, then you get to 1. Now after that, you are supposed now to come here and say that for the first case, you are supposed to substitute x with 1. So when I substitute x with 1, I'll end up by having k 1 cube, because x is cube, divided by 3. Then for the second case, I subtract. Here I have the lower limit as 0, so I'll just substitute here where x is. I'll just substitute with 0. So when you do so, I'll be having k 0 cube. So that's what I write here. So it will be k 0 cube divided by 3. Then you get everything to 1. Now after that, now you are supposed to work at the brackets. So 1 cube is just 1, so you end up by having k over 3. Then 0 cube is 0, so when you take 0 by k, probably 0. 0 divided by 3, that is 0. So the other side is just 0, is equals to 1. So to remain with k here, you are supposed to multiply by the reciprocal, that is 3 over 1 times 3 over 1, which when you do so, you will finalize by having k being equals to 3. Now that's the first question I prepared for you. Now the B part of it, I want us to look at the B part of the equation so that we can see how we can solve that. Now under B here, let me write the equation under B. You are now being told to find the values of A and B such that, now let me write the equation first, is we see the solution onto it. So find the values of A and B such that Roman 1, for the first case, Roman 1, that is probability of x less or equal to A being equals to the probability of x greater than a. Yes, so you've been told to find the values of a and b such that the probability of x less or equal to a being equals to the probability of x greater than a. And remember, already you've gotten the value of k here. So we shall be substituting where k is, we just substitute with the 3 there. Now let us see the solution on this problem here. So that is a solution. Now in this case here, your work is to identify the upper and lower limit. Remember, for the case of x less or equal to a, that one means that my upper limit shall be a. Remember, my upper limit shall be a and my lower limit shall be 0. That is it. So this case, when I put the integration sign here, my upper limit shall be a, my lower limit shall be 0. So when you do such, you are supposed to come here. Remember, I was having, that is a kx squared, and my k is already 3. So I'll just substitute where k is, I just substitute with 3. So I'll come here now and say that it is now 3x squared dx. Remember, I'm integrating in terms of x. This one must be the same as the probability of x being greater than a. Now let us look at here. X greater than a mean that my upper limit, remember, my upper limit shall be 1 while my lower limit is now a, because when I put the integration sign here, x is greater than a, meaning the least value of x is a. So I'll come here and write a here. Then the summation, the total probability under PDF, remember, it can't exceed 1. That's why we are putting here 1. So when you write any other value beyond 1, that one you shall be wrong. So the highest, the maximum is 1, and the least is a. So this one, I write now that is 3x squared. You just come in and write 3x squared, but it is in terms of x. So that's why we are getting, that is dx. Now after that, now you are just supposed to integrate. So when you integrate this, remember, I'll be adding 1 to the power. So 2 plus 1, that is just 3. So I'll end up by having now, that is 3x raised to 3. Then you just divide by the total power here. After that, you write the limits here. So the limit, that is the upper limit is a, the lower limit is 0. Then I now equate that one to, that is here. When I integrate this, probably I'll get the same. That is a 3, that is x cubed over 3, and you write the limit. The upper limit is 1, the lower limit is a. Now after this, now you substitute. For the first case, you substitute when x is a. The second case when x is 0. So you will come here and say, and remember, before I come there, when you look at here, these 3 cancel, these 3 cancel, these 3 cancel, these 3 cancel. So that now I now come here and have that it is now x cubed. The limits I have, that is a0 being equals to, that is x cubed, and the limits here I have 1 as well as a. Now when you come here and substitute for the first case, x being equals to a, it shall now come and say that it is now a cube minus, now for the second case when x is 0, so I'll come here and write now 0 cube there, being equals to here for the first case x is equals to that is 1, so I'll come here and write 1 cube minus, for the second case x is equals to a. So just substitute where x is, just put a. So that is a cube there. Now after that, remember this 0 cube is just 0, that is useless. So when you write the remainder and you collect the like terms, because this a can come this side, so that you get to 1. So you will end up by having, that is a cube plus, because a negative when cross the equal sign, that is a positive, so plus a cube being equals to 1, because a 1 raised to any number, it is just 1. So 1 raised to 3 fortunately shall be 1. So when you work out this a cube plus a cube, that is 2a cube being equals to 1. So I need to be dividing by a, that is 2. I divide by 2 here, such that these two cancel and I remain with a cube that is equals to 0.5, because half is just 0.5. Now after this, your work is just to get the cube root. So just come here and get the cube root of a, get the cube root of this one here, that is a cube root there. So when you get the cube root, that is a cube root of that is a 0.5, that is 0.5 there, you will end up by having a as 0.79, that is 37 as your value of a. So for the first case here, we've identified that for probability of x less or equal to a to be equal to a, probability of x greater than a, my value of a shall be 0.7937. Now that is the first case. Now let us look at the second case, that is Roman 2, so that we can see how we can perform that. Now you are now being told that the probability now x being greater than b is equals to 0.05. that is it. Yes, and remember here it is just part of b. The b part of the equation was to find the value of a and b such that probability of x is greater than b being equals 0.05. Now the first thing you need to be asking yourself is the limits, because when I put the integration sign here and my x is greater than b, what does this mean? For x greater than b mean that the lower limit is just b, the lower limit here is just b, and if the lower limit is b, meaning the maximum shall just be 1, and therefore the upper limit is just 1. Then remember we were having here that it is now kx squared, and already we've gotten k as 3. So when I say now 3x squared, I'll just be right. So I'll come here and write and say that is 3x squared dx. Remember we were integrating in terms of x. The result is equals to 0.05. Now after this, now your work is just simple. You are supposed to integrate in terms of x. So when you integrate this, you will end up by having, that is 2 plus 1, you shall be having 3x cubed, because 2 plus 1 is 3. Then you divide by the power, that is 3. Then you write the limits here. The upper limit is 1, the lower limit is b. The result is equal to 0.05. Now after this, now you can see that these 3 cancel these 3 there, so that I now remain with, that is x cube having the limit that is 1 and b, the total result being equals to 0.05. Now after that, you just substitute for the first case x equals to 1, and for the second case x equals to b. Then from there you shall be in a position of getting the value of b. Now let us go. So for the first case, when x is equals to a, it shall be 1 cube minus, for the second case, when x now is equals to b, it shall be b cube. The total result is equals to 0.5. Now from there you are supposed to now collect the like terms, whereby I can intend to bring b the other side, then this one I bring this other side, whereby I have 1, because 1 cube is just 1. So I have 1. When a positive 0.05 cross the equal sign, it is negative 0.05, being equals to, when a negative b cube crosses the equal sign, it shall be b cube. Now when you take 1, that is 1 minus 0.05, that is you will end up by having 0.95 being equals to b cube. Now for this case, your work is to get the cube root there. You get the cube root of that, whereby now when you get the cube root, you will end up by having b being equals to, so when I get the cube root of my answer there, you will end up by having your answer 0.9, that is let me write 0.983 as your final answer in terms of b. So you will end up having gotten a as 0.7937 and b as 0.983. You will be in a position of getting the final answer to question b, whereby we were getting the values of a and b in terms of those Roman 1 and Roman 2. Otherwise, having gotten the concept I prepared for you today, let me meet you in the next class. Otherwise, bye.